Previously in math class, we talked about one inequality and two variables. Now we're going to have what's called a system of inequalities. That's when you have two inequalities or more at one time. Let's continue where we left off. All right. Let's look at these guys. These guys here. The first one has two inequalities. And remember the process for each inequality. We're going to draw the associated line, do a test point, and then do the shading. Do not go on to the next inequality until you've graphed the first one completely. So the first one, we're going to graph the associated line x plus 3y equals 6. Remember, the fastest way, in my opinion, to do this is by x and y-intercepts. An x-intercept occurs when y equals 0. If y equals 0, there goes the 3y term. So what would that mean x is equal to? 6. So along the x-axis, we're going to put a dot at 6. A y-intercept occurs when x is 0. If x were 0, there goes the x term. So we'd have 3y equals 6 or y equals 2. Are we going to use a solid or a dotted line? Solid y, because it's got an equal to on the inequality. So connect your dots with a solid line. Also, use a ruler, but please label your line with the equation. Now we do our shading. Pick a point, any point, as long as it's clearly not on a line. From last class, the popular point became 0, 0. So you're going to put in 0 in for x, 0 in for y, and you're going to ask yourself, is this true or false? Is 0 plus 0 less than or equal to 6? Yeah. 0, 0 is in what relationship to the line, above or below? Below. 0, 0 is below the line. 0, 0 made it true. So what side do we shade on? Below, because that means all points below the line are true. Again, no wimpy shading. If you want to use colored pencils, go right ahead. If you want to stipple, go right ahead. Art term, you're welcome. One person, two people. No, stippling, the dots. Yeah, takes forever. Yeah. But it's fun. Looks nice. All right, we've completed the first inequality. Now we mosey on to the second one. We're going to graph the line 2x minus 2y equals 4. What's the corresponding x-intercept? 2. Because if y was 0, there goes that term. So 2x equals 4, so x equals 2. What's the corresponding y-intercept? Negative 2, because if x was 0, you could get negative 2y equals 4. So y is negative 2. Solid or dotted? Because we have an equal to sign on our inequality. Remember, we're going to call that non-strict. Connect the dots. Write the equation, please. Do I have to write the equation? No, but breathing's also optional. We can pick 0, 0 again. If we put in 0 in for x, 0 in for y, is this true or false? False. 0, 0 is above the purple line. 0, 0 made it false, which means all points above will make it false, which means all points below will make it true. So we're going to shade below. You always shade the true side. In America, in Britain, they shade the false side. Anyways, so anytime you do a shading, that's called a half plane. Remember, a full sheet of paper that extends forever is called a plane, P-L-A-N-E. So by drawing the line, you're cutting in half. And when you shade one side, that's called a half plane. So we're finding where the overlapping half planes are, if there is such a place. Please, 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 always shade that one the darkest. So what you're saying is all these points in this region satisfy both inequalities at the same time. But just so you know, all this region is good to go, and any border of it will satisfy. So if you pick any of these points, you will find an ordered pair that makes both inequalities true at the same time. This region has a name. It is called the feasible region. Feasible region. So instead of saying final answer, we just say feasible region.